74,000 years ago, a mountain on the island of Sumatra exploded with a force no human has ever witnessed. It wasn't a volcano. It was a supervolcano. And when it erupted, it didn't just destroy a region. It nearly ended our species. Scientists call it the Toba eruption. And what happened in the years after is more terrifying than the explosion itself. The explosion. The eruption ejected an estimated 2,800 cubic kilometers of material into the atmosphere, enough to bury an entire continent under a layer of ash. For comparison, Mount St. Helens in 1980 released less than 1 cubic kilometer. Within hours, ash clouds blocked out the sun across South Asia. Within days, that ash had spread around the entire planet. Geologists have found Toba ash in soil samples as far away as East Africa and the Arabian Sea, a layer of fine gray dust that settled over thousands of kilometers, some of it more than 10 centimeters thick, even at extreme distances from the volcano itself. But the explosion was just the beginning.
Why we're still here. So how did anyone survive 6 years without reliable sunlight, with crops failing and animals dying across entire continents? The honest answer? We don't fully know. But evidence from coastal sites in South Africa suggests some human groups survived by shifting almost entirely to marine resources: shellfish, fish, anything the ocean could still provide when the land stopped producing. Other groups may have simply been in the right place, with the right resources, at the right moment, while entire populations elsewhere vanished without a trace. Archaeological sites in southern Africa dated to this exact window show advanced tool use and symbolic behavior, evidence that the survivors weren't just lucky. They were adapting, innovating, holding on by sheer ingenuity while the rest of the world went dark. Some researchers believe this period of intense pressure may have actually accelerated human innovation, forcing small, isolated groups to develop sharper tools, better cooperation, and more complex planning just to make it through each season alive.
The human bottleneck. Here's where it gets personal. Genetic studies suggest that the entire human population at this time may have crashed to as few as 3,000 to 10,000 breeding individuals. Think about that. Every single person alive today may be descended from a population that small, survivors of a near-extinction event most of us have never even heard of. This is called the Toba catastrophe theory, and while some scientists debate exactly how severe the population crash was, the genetic bottleneck itself is well documented. Human genetic diversity is unusually low compared to other great ape species, a strange fact that this theory may help explain. Chimpanzees living on a single hillside in Africa often show more genetic variation than humans do across the entire planet. Something thinned us out, hard, and not that long ago in evolutionary terms.
How we found out. For decades, nobody connected the dots. Toba was just a quiet lake in Indonesia, beautiful, deep, unremarkable to anyone who didn't know its history. It was geologists studying volcanic ash layers around the world who first noticed something strange. Identical ash deposits, the same chemical fingerprint, buried in soil on different continents, all dated to roughly the same moment in time. Piece by piece, researchers traced every sample back to a single source: one eruption, one mountain, a blast so massive it left a signature on nearly every continent on Earth. That's when scientists started asking a much darker question. What did this do to the people who were alive when it happened? 6 years of darkness. Sulfur dioxide pumped into the stratosphere formed a global aerosol veil, a layer that reflected sunlight back into space. Global temperatures dropped by an estimated 3 to 5 degrees Celsius. In some regions, the drop may have been far more severe. Plants died. Photosynthesis slowed across the planet. The food chain that every living creature depended on began to collapse from the bottom up. Evidence from ice cores in Greenland shows volcanic sulfur signatures so extreme that some researchers believe the climate disruption lasted not months, but years. Some estimates suggest up to 6 years of significantly reduced sunlight and cooling, with effects lingering for a decade or more afterward. Lake sediment records from Africa show a sharp drop in pollen during this period, direct evidence that entire forests thinned out or vanished within a few short years, replaced by grassland and bare soil where dense woodland once stood. The mountain that remains. Today, Toba is a lake. Lake Toba, the largest volcanic lake on Earth, sits in the caldera left behind, beautiful, calm, and almost completely forgotten by everyone except the scientists who study it. Tourists visit its shores without ever realizing they're standing inside the scar of a near-extinction event. The caldera stretches nearly 100 kilometers long. An entire island, Sumatra, rises from the middle of the lake, itself formed by the slow resurgence of magma pushing the crater floor back upward over tens of thousands of years. But the volcano isn't dead. It's dormant, and supervolcanoes like Toba are believed to erupt at this scale roughly once every several 100,000 years. We are, geologically speaking, overdue. And Toba isn't alone. Yellowstone, in the United States, sits on top of one of the largest supervolcano systems on the planet. It has erupted at a similar scale before, and geologists monitor it constantly for any sign of change. Most of the time, nothing happens for hundreds of thousands of years. And then, without much warning, everything changes at once. What this means: the Toba eruption isn't just an ancient disaster story. It's a reminder that human civilization, all of it, everything we've ever built, exists in a narrow window of climate stability that nature has interrupted before, without warning and without mercy. We live in cities of concrete and glass, in systems built on the assumption that the sky will stay predictable, that the seasons will behave, that the sun will keep doing exactly what it has always done. Toba is proof that assumption has failed before. No civilization existed yet to be destroyed when Toba erupted. Just small bands of humans, scattered across a handful of continents, holding on to survival by the thinnest of margins. We survived it once, as a tiny, fragile population clinging to the edges of survival. Next time, there will be cities. There will be billions of people. There will be far more to lose. We may not get the same warning next time.